Hi everyone, welcome to ITS workshop. In last video we have seen the theoretical explanation of map and reduce. What is map reduce programming model, and we discussed many points. What is mapper, what is reducer, like that. And the agenda for this video is building our first map reduce application and running it successfully against our dataset. So as we know that MapReduce application can be divided into two phases. First map phase and then reduce phase. Both phases uses key value pair as input and output. The implementer provides map and reduce function. So the user just need to take care about the map logic and the reducer logic, and the rest of the distributed programming things like splitting and distributing of your data of your map and reduce task around the cluster is taken care by framework itself, so we don't need to bother about these things. So we have two things here. First is job. Everything, your application, your full program is submitted as a job so that you can execute the job, you can control the job, and if something goes on you can see the parameters, why it could failed, or how much it is getting completed. Like you'll see those data, 0% map has been done, 50% mapper done, reduce done, like that. So execution of map and reduce function to accomplish our task, a full application is submitted as job, and this can be considered as like we have main method in Java, normal Java application. So this job is like main method for your Hadoop application, for your MapReduce application. Then there is something known as task. What is task? A single mapper or a reducer can be considered as task. So job can be divided into multiple tasks. Each task is performed and then full execution takes place. So first job will be word count job. This is one of the very classic and famous example for writing MapReduce application, word count program, and this is my data set. You can take any text file for this. I'm taking this text file. This is deck of card text file, and which contains 52 cards. Like we have cards both in both color, black and red, and there are four types: spade, club, diamond and heart, and different values like 2, 3 and queen, and etc, etc. So I have 52 cards. I want to perform various analysis for this. For example, I can ask like how many cards do I have, how many rows do I have in this text file, or how many blacks I have, or how many reds I have, how many clubs are there, how many black queens are there. I can ask like that, how many red queens are there. So this kind of information taking out from your data set is one analysis. So we would like to read this file programmatically and we want to perform some analysis. So this is my input file, which is a text file, and we want to perform word count, like number of blacks. First we'll start number of rows, how many cards do we have. So how the application proceeds is it splits your text into tokens. Then for each first letter we want to sum up the occurrence. That's how word count works. Everything is divided into token. Then for each first letter of from each token, we just want to calculate the total number of occurrence, how many times particular token with a particular word is coming. Like in this example, how many times the letter something which starts from capital B is coming, and how many times something which is starting from R is coming, like that. So that can be your word count. Then we will generate output in a local directory. This can be performed using SDFS as well as local file system. But in first case, starting case, I'll be taking my input file from local file system and I'll be putting the result back to local file system. So For a word count job, for writing this application, there are four things which we need. First, we want to configure the job. We want to specify the input, the output, the input path and the format of the input, the output path and format of output, which mapper we are using, which reducer we are using, or which combiner are using. Mapper and reducer are compulsory, combiner is optional. This will come in optimization stage. And then after configuring your job, you need to define your mapper, and then you need to define your reducer. And in mapper and reducer, just write one mapper class which is extending to the generic mapper class, and you are specifying your map method, you are specifying for your reduce method. Then you just run the job. So there are four stages which you would like to perform. Okay, so let us start. Make sure you have Eclipse, Java EE, and because I would like to run this application using Maven, I'm going to prepare a Maven project for this. And the other requirement is make sure your Hadoop is up and running. So if I give JPS command, it will show me which Hadoop daemons are up and running. So we have data node, resource manager, node manager, name node, secondary name node. Everything is fine. You can open the browser and you can check localhost :50070. In my case, because I'm not using any special version of Hadoop, any vendor specific version like Cloudera or Hortonworks, I'm using plain vanilla Hadoop, you can say. This is just Hadoop installation on Linux machine. If you don't know how to install this, go back to my previous video and check the installation. For right now, it is up and running. We performed some SDFS specific task. Okay, so my Hadoop is up and running. I have Eclipse. Then let me show you my input file. So in my home folder, I have created one directory, map and reduce. Here I have given this input text file, deckofcards.txt, which I just showed you here. This is my text file, only 52 lines, and this kind of result directory will be generated after running our program successfully. So this is the result. Previously I ran this application, I got this result, and now again we'll use this same path for input and output. So let us start writing our first map reduce application. And first of all, let us create a application using Maven. So I want to create a Maven project. Then just click next. I'm using quick start, then next. And so in last, if you don't know how to create a normal basic Maven application using archetype, you just go to my previous video and check that, and you can just follow these steps also. So I'm giving this word count. My project name is word count, and it comes under this group org category. This is like wordcount.org, wordcount.com, like that. And this will be a jar file with this version. Then you can say finish. So we got one project, word count, and this is our POM file. This is basic structure. The advantage of using quick start is it gives us basic structure for Maven project. Right now you can see in dependency there is only one dependency resolved, which is JUnit. But we want to tell our program that this word count project is going to handle some Hadoop stuff. So we need those libraries. There are two ways you can do. Either you go online or you download each and every dependency jar by yourself and then you put in your project. But since we are using Maven, we don't have to do that. We can just copy the POM file from the previous run Hadoop programming, like we did HDFS, Java API, the all SDFS related programs. If you don't have this POM file, please find this in comment section and this POM file will be different for your Cloudera version if you are using Cloudera VM. So I'll put both option for you, and I'm just copying the required stuff. After JUnit, I'm copying everything, and I'm going to put here, so dependency tag, and then this paste. Fine. Then I'm going to save this. It is building my project. If you are doing this very first time, it may take some time. It will go to internet. Make sure you are connected to internet. It will go to internet. It will download all the required dependencies, and but if you are doing it second time or third time later, if you have already done this, then it won't take much time. It will just copy those dependencies jar from the local repository. So I gave dependency according to my Hadoop version. This is Apache Hadoop SDFS 2.7.3, because I'm using Hadoop 2.7.3 version. But if you are using different version, make sure that you specify your correct version, or it can be Cloudera or any specific version which you need to check in your dependency. For me, this is working fine. Okay, now if if you go to your WordCount project, and if you see maven dependency, all Hadoop jars are there. So these are what we are looking for, and we'll write our program. So we can close this file, and we can start from writing our first application. This is just app.java come with a hello world program. When you are creating project, I'm just deleting this. Then we have an empty package. I'm going to create a new class, and I'm going to name it as WordCount driver. So this will be my main driving class, where I'll specify the information about job, which is my input path, which is my output path, and this class will contain a main method. So my application will start from here. And if you are developing MapReduce application in future, then you may use this class as it is. You can just change the specific information about which mapper you are using. So this will be common throughout our application. Okay, so let us start writing our main class. Public class WordCount driver. First of all, let us have a main method. Public static void main. We have a main method, and now this is just a simple Java class. Now how we tell that we are going to use it for Hadoop? So there is one thing. We want to configure our job. We want to submit our application as a job, and we want to configure it. So for configuration, we need to extend configured class. You can import this, and these please pay attention while you are importing any stuff. Right now there is only one configured org.apache hadoop conf, so you can import this. Don't import the wrong one. And then we want to handle some runtime argument, like you are a developer and you are developing your MapReduce application. You have provided your logic and all stuff, then you created jar file, then you are submitting your jar file, you are handing it over to your the admin person, or the person who is responsible for running your application. So he'll just take your jar file, then he would be supplying the input path, output path for your analysis, and with what is main class. So definitely we are going to use some command line option, generic command line option. So if you want to use generic command line option, you have to implement tool. Now if you don't understand everything in this program, like what is configured, why only tool, then don't bother about these. We'll discuss these things, each and everything in detail. Right now we just want to write a basic application and we want to run it. So I'll just give you some introduction hint why we are using something. Configure because we want to configure our job, and tool because we want to handle some command line option. Now you'll find this that because you are implementing tool, there are some unimplemented method. So you would like to implement those. And which method is unimplemented? That is run method, which is returning something integer. And run method is also accepting same argument which you will be supplying in your main. So from main we'll call run method, and run method will also accept same arguments. That's the logic. Okay, so let us write our run method. In run method, the first requirement is we need a job instance so that we can execute our application as job, and we can control job dot get instance. Now get instance, you can consider this constructor which is using a configuration object and a job name. So job name can be useful when you are monitoring your application. So I would like to use this. And configuration provides the underlying configuration. So I can just say get conf method, which will give me the configuration. Then I can provide my job name. So we can say this word count, or you can give any name what you like, it's just for monitoring. So this getConf method goes back to your Hadoop setup. This is your Hadoop installation. It comes here and it checks all these configuration file. It reads this, that what is your configuration, how you have installed your version of Hadoop. Okay, so we have given job. Now we have a job instance. The second thing which we can configure output and input source. So text input file, text input format dot add input path. Now add input path will accept a job instance and the path of input. So text input format is one of the basic class which is saying that we are going to use a text file as input, and we want this path to be our path for input. So we have provided job instance, and now we are going to provide a path. So a path will come, you can hard code your path, but I want to have my path coming from my argument, coming from my command line argument. Sorry, this is not args, this is 0, and we can say 0, and you can import this path which is in hadoop.fs. It says, so whatever command line option you are giving here, will the 0th command line option will come for input path. That's what we are saying here. Then the next thing is we can have job dot set input format class. Now we want to tell our program that what is going to be my input format. So if you don't specify anything, it uses text input format, but because we are already using text input format, so you can specify text input format dot class. This is going to be my input. So input file path and type of input format. Then the next thing you can do, you can specify what is going to be my output format. So after input you can tell what is going to be my output format, and there is same method for doing this. You can do text output format dot set output path, and we can provide a job instance and a path instance. This is fine, you just give a job instance and then you can give a path instance. So again I'm taking path from command line, and my first argument will be my input path and my second argument will be my output path, which is referred as 0 and 1. Then the next thing you need to specify, like we specified set input format class, we can specify that job dot set output format class. This is going to be my output format class, and again you can say we are getting output as text, so output format dot class. Okay, so we have specified input path, input format, output path, output format. Now the next thing we need to specify which mapper I'm going to use. So job dot set mapper class, which mapper class I'm going to use. So right now we haven't created any mapper class, but I'll create this WordCount Mapper dot class, and it is showing error because there is no class WordCount Mapper, which will create in next step. Job dot set reducer class. So for this program we are not creating any reducer. We can use some of the well-defined reducer which comes in the library. I'm going to use int sum reducer because we just want to calculate the total, the summation of our small file. So I can use this, and you can import this also. Int sum reducer, import from MapReduce library, reduce. Okay. Now the next thing, we need to specify input key type, output key type, and input key type, input value type, output key type, output value type. And in some cases when both are same, then you can just specify the output key value type. So job dot set output key class is going to be text. So if you don't understand, okay, what is text now, so don't bother about this, we'll study this. For time being, just consider that this is my basic class for text type. We are going to have our input key as text, and you can import this text. Make sure you are importing from the correct, there are many text, we are importing from Hadoop IO. If you are doing wrong import, it may give error. Everything should be from Hadoop. Then we need to tell what is going to be my output value class. And we can create our own key value types. In the coming series of videos, we'll be doing all those stuff. And my output value, I'm going to take int writable. There are some standard key value types available. We'll discuss these, and for right now we are using these two. You can import int writable also. there is one mistake in try table, then import this. Import this Hadoop IO. So we have in try table and all looks good. Okay, so we have a job instance and which is taking the configuration of our Hadoop, and we have given it a name. Then we are specifying that this is going to be my input path. Here my input file exists and this is my format of input file. Here I want to generate my output, and this is going to be format in which I want to generate output. And this mapper is being used by my driver class or by this application. This reducer should be used by this application. Then we are specifying the key value type. So if both are not same, we have to specify map input key and map output map input value separately, but both are same in this case, so we can just say output key and output class. Output key is text and output value is going to be int writable. So these are just some type. Text can be considered some parallel to string data type in Hadoop, and int writable you can consider like counting in integer, but it is going to be a writable, comes under writable. So we'll see these things in detail. Now the next thing what we want to return. So for returning we can have job dot wait for completion. Now wait for completion method is very helpful. We can monitor our job and we can see how it is proceeding, all this information. And if it is true, if our job is running successfully, it gives us result successfully, then we want to return 0. Otherwise we want to return 1. So 1 specifies job got killed or it was not success. So it is useful for fetching all those parameters related to your job, how it is doing and where it got stuck, like that. So we have run method which is returning some integer. If job is successful, it will return 0. If job is not successful, it will return 1. That's what we are saying here. Now let us come to main method. In main method we can specify how I'm going to execute my job using tool runner. So we need, because we are using tool, because our class is a tool, because it is implementing tool, so it is also some type of tool. And for accepting some command line option, we are using a tool runner to run our job. So tool runner dot run method which will accept a tool and string argument. So what is our tool here? I can say my word count, driver is my tool, and args will be supplied like this. Now it says that we are not taking care of exception nicely. I'm just saying at throws. So we are using tool runners run method for running our application, and it accepts two things. One, the tool object. This is tool object. Right now word count driver is implementing tool, so this is tool object, and then we are taking these command line arguments. So these command line arguments are passing to this run method, then coming here, then will give input and output path here. So if the exit is 0, it means our program is running successfully, then we can come out of the execution. So system.exit method is taking exit. So if it is 0, it will come out of the execution. If it is 1, it means some problem is there. That's how we are doing it. Okay, So we got run method and we got main method in which we are calling this run method. Now let us come and write our mapper, because we need one more thing. Only one thing is showing error here, word count mapper, because we haven't defined it yet. I'm going to create my mapper word count mapper class. I think I gave a typo. It's not. I took a small w. Make sure. Take the. Okay. So we have renamed it, and it's fine. So right now this is just a simple mapper class, and how we are going to tell just a simple class, not a mapper class. So how we are going to tell Hadoop that consider this class as my mapper? So we can subclass this with the generic mapper class. So we have a mapper class, and we can specify the type, input key type, long writable, input value type is going to be text, output key type is going to be text, output value type is going to be int writable. If you don't understand what is int writable, what is text, why we are doing this, please wait for the coming video. I'll define everything there. So long writable, we can import text, first we can import mapper, then we can import long writable from IO and text from Hadoop IO. Fine. Then we can import int writable from IO. So my class, which is word count mapper, is a child class of generic mapper class, and we are defining input key type, input value type, output key type, output value type. It takes 4 things. Okay, so the mapper class has map method, and we want to override that map method so that we can provide our logic of handling data. Protected void map, which accepts 3 things. First, what is input key type? So in this case we have already taken it as long writable. Long writable is going to be my key type. Then we need to specify what is going to be my output type. So my not output type, input key type, input value type. So input key type is long writable and input value type is text. And the third thing it accepts is context, and context object can be used for writing the output. So I am taking context object, and then we can specify the logic of handling this, logic of handling our data. So we only need to produce one thing. Right now I'm not going with specific tough complex logic. I just want to count my number of cards or number of lines in that text file. So I can say context dot write, and context dot write is a method which accepts which is expecting 2 things. First, what is going to be my output key type, and what I am going to be output value type. So these two things, text and int writable. So it is accepting something as text. You can say new, what is text here, new text object, and you can say value dot to string. So I just want to print out whatever input I'm taking, I want to print out same as output key. And the second thing I'm defining here is int writable. So right now I don't need any logic, and if you don't understand this, don't bother about mapper. I'll create a different separate video for mapper class. You can save this. Now it says for exception, you can throw this exception. In this video I just want to summarize the basic skeleton application so that we can proceed further, then we'll go deeper and deeper. So I created one class which is a child class of generic mapper class, and this is input key type, input value type, output key type, output value type, and it has got map method. Inside this map method we are providing the logic of analyzing our data. So it is taking input key, which is long writable, and input value, which is text, and then context. So I just want to write I want to take same input key, and I just want to make same value as my output value, and with same int writable. So it will produce result like one line, same input line, and with one int writable one. We are just mapping each line with one letter, each line with a numeric 1. We are doing that. So each line will be counted and each line will be mapped with 1. Then in the second stage, in the int sum reducer stage, so int sum reducer will calculate all these ones, how many ones are there. Okay, so we have done this. Now everything seems ready. We have a driver class, we have a reducer class, and go to your project and right click. Then you need to create configuration. So in configuration you can provide the name of your configuration which you are going to use. I want to name my run configuration as word count, and then you can select your project. Okay, my project is going to be word count. Then you can select your main class. So in our case my main class is word count driver. I'm saying okay. Then you need to provide some argument. So you remember this thing that these arguments are input and output. So the first argument, you need to specify this argument, what is your input file. So I want to feed my input this deck of cards.txt. So just go and copy the path. This is my input file path and this is my name of the file. So come to Eclipse and paste this input path and input file, then one space. After one space, the second argument. The second argument will be my output. So since result 1 is already existing, I'm giving it result 2. I want to generate output in same path as named as result 2. Then you just say apply and run your application. Now if you are doing any error or if you are doing something wrong, you'll see a lot of messages coming here, and this time it looks like it runs successfully and result 2. Okay, so this is success and we are getting this result file. So in result directory you will see these two files. This is some system use file with written as underscore success, and this will be your result file. It is by default it is named as part 0, part 0 like this, and you can read this result what we are doing here. So this is mapping each line with 1. We are mapping each line with 1, and we are doing reduce also, but we are doing reduction only for total key. So black club 10, there is only one combination of black club 10, so it says 1. So even after this reduction phase also we are getting 1 here. So first it is mapping each line with 1, then it is counting for all this combination black club 10 how many things are there. So it says 1. Okay, so this is our first program. We are mapping each line with 1, then we are counting the variety of each line. So there is only black club 10. Okay, so let us do it separately. Like if like we have black club 10, and I'm copying this black club 10 again some 4 times. I'm saving this in my card file, and I want to run this application again so that we can understand how it is mapping and how it is counting. So just right click, run configuration. I need to change only one thing, my output directory. I want to save my output in result 3, apply and run. So this is also successful, and we can check our result. Come to result 3. Now you see black club 10 4. So in my input file I just copied black club 4 times. So in the mapping phase it just put this map 1. So black club 10 is marked with 1, black club 10 is marked with 1, all 4 lines marked with 1 like that. Then it is calculating how many ones we have. So for black club 10, for the key black club 10, it has 4 number of black club 10. That's what reduction is doing. So mapping is just marking it, just mapping it with some variable, not variable, with some value. In this case it is integer 1. We took integer 1, and then in reduction phase it is summing up those things, how many times it is occurring. So black club 10 is occurring 4 times. That's what we are doing. So this was one of the very classic example of map and reduce application. And if you like this video, if you are liking my tutorials, please subscribe and click on bell button for any notification. Now I'll be creating more stuff, more detailed stuff with map reduce application, and we'll see each and everything in detail with mapper, with reducer, with combiner, and a lot of stuff and projects with Hadoop. Thanks for watching. Thanks a lot.